All right, you know that long S-shaped symbol in math class? The one that just makes your brain kind of shut down? Well, today we're going to tackle that thing head on. This is all about making integrals simple. I promise, by the end of this, that symbol is going to look a whole lot less scary. Let's do this.
Okay, so to get this, let's start with a really simple idea. Math is full of opposites, right? You've got addition and subtraction, multiplication and division. A while back, we talked all about derivatives. That's how you find the rate of change of something. But what's the opposite of finding change?
Yeah, let's really focus on that question. If a derivative is like slicing something open to see how fast it's changing at one exact moment, what's the tool you'd use to do the opposite? You know, to put all those tiny moments back together? That's the big puzzle we're going to solve right now.
And the answer is the integral. Now, don't let the name scare you. The main idea, the big idea, is actually super simple and really powerful. At its core, an integral is just a super-powered way of summing things up.
Summing what up, you ask? Well, imagine trying to find the total of something by adding up an infinite number of teeny tiny microscopic parts to get the whole picture. It's kind of like how a digital photo is made of millions of tiny pixels. The integral is what lets us add up all those pixels to see the final image.
So, this gets us right back to that opposites thing. Think about it this way. A derivative tells you your speed right now, but an integral, that tells you the total distance you've traveled. A derivative is about how things are changing, but an integral gives you the total amount.
And this visual, this is pretty much the key to the whole thing. So look at this weird curvy shape. How on earth would you find its exact area? Well, here's the genius move. The integral slices it up into an infinite number of super thin rectangles. And once you have those, well, you just add up all their little areas to get the big one. That's the magic right there.
Okay, so we've got the what down. Now for the how. I mean, the concept is cool, but let's get our hands dirty and actually solve one. And the best part is, for a ton of these problems, you really only need one big rule. It's like the secret code.
And boom, here it is, the power rule. Now I know, lots of symbols. Don't worry about it. That squiggly thing is just the integral sign. The dx tells us what variable we're using, and the rest is the magic formula. We're going to break it down into 3 super simple steps, seriously.
So yeah, that formula looks a little intense, but it really just boils down to this. Step 1, you take the exponent and add 1 to it. Step 2, you divide the whole thing by that new exponent. And step 3, and this is important, you always add a plus c at the end. You're probably asking, why? Well, think about it. When you find a derivative, any plain number just disappears, right? It becomes 0. So when we go backwards, we add this c as a placeholder for any number that might have vanished. It's called the constant of integration.
Okay, enough talk. The best way to really get this stuff is to just do it. Let's put this rule to the test and actually solve a couple. You'll see how it all clicks into place. All right, let's start with our first example. We need to find the integral of 3x squared. Let's just walk through our 3 steps.
Okay, so step 1, increase the exponent. Right now it's a 2, so we add 1, and that becomes 3. Easy enough. Step 2, divide the number out front, the coefficient, by our new exponent. So that's 3 divided by 3, which is just 1. And step 3, put it all together. We get 1x cubed, or just x cubed. And what do we not forget? The plus c. See? Told you it wasn't so bad.
Okay, ready for another one? Let's try the integral of 4x. Now, this one has a tiny little trick to it, but once you see it, it's super easy.
So here's the secret. Whenever you just see an x, you have to remember it has a little invisible exponent of 1. It's really x to the power of 1. Once you know that, the steps are exactly the same. So 1 plus 1 gives us our new exponent, which is 2. Then we divide the 4 by that new exponent, 2. 4 divided by 2 is 2. And boom, we put it together. 2x squared plus c. Done.
Okay, so we can follow a rule. Big deal, right? But what's the point of all this? Well, this is where it gets really cool. This is the moment it all comes together. We're about to use this abstract math to find a real, actual answer to a problem you can see. This is the big payoff. So have you ever seen that integral symbol but with little numbers at the top and bottom? That's called a definite integral. And what it means is we're not looking for a general formula anymore. We're looking for one specific number, the exact area under a curve between 2 specific points. So let's do one. Our mission is to find the area under the curve y equals 2x, but we only care about the part that's between x equals 1 and x equals 3. And the way we like that out is with our integral sign, with a 1 at the bottom and a 3 at the top.
Okay, the process for this is pretty straightforward. First, you find the integral just like before. So the integral of 2x is just x squared. And for these definite integrals, you can actually forget about the plus c. It just cancels out anyway, so we can ignore it. Now, you take the top number, 3, and plug it in. 3 squared is 9. Then you take the bottom number, 1, and plug that in. 1 squared is 1. And for the final step, you just subtract the bottom result from the top result.
So 9 minus 1 is 8. And that's it. That's our answer. The exact area under that line between those 2 points is 8 square units. How cool is that? We just used a bunch of symbols to find a real physical area. That's what makes integrals so powerful.
Seriously, look how far we've come. We went from a scary-looking symbol to calculating an actual real-world area. So let's do a quick recap of the most important things to remember, so you can really lock in this new math superpower. Okay, here are your pro tips. First off, if you're doing an integral without those little numbers, an indefinite one, you always have to add the plus c. Don't forget it. Second, integrals mean you increase the exponent by 1. It's so easy to get that mixed up with derivatives where you decrease it. So yeah, third point, keep those 2 sets of rules in different boxes in your brain. And finally, the best tip for any math ever, just slow down. Check your work. It makes all the difference.
So let's end on this thought. Today, we used an integral to add up a bunch of tiny rectangles to find an area. But that core idea, summing up infinite tiny pieces, is used for, well, everything. It's used to calculate how much water flows through a dam, to model stock prices, to design airplane wings. So it kind of makes you wonder, right? If you can find the area under a curve, what else in the world could you add up to understand it a little bit better?